Hello, everybody. In this video, I'd like to talk about the efficacy rate of a vaccine, how you calculate it, what it means, and what it does not mean. We will look at the real data published by Pfizer and cited by an article in the New England Journal of Medicine in late 2020. So let me share my screen with you first, and we will get going. All right, so what is efficacy? We will look at data published by Pfizer, and my primary sources, and there are two sources that I will be looking at. One is the article published by Pfizer in 2020, and the other one is an article that corresponds to that Pfizer article, but this one was published in the New England Journal of Medicine, and you can see both of these. These are accessible online on the internet. In fact, let me just show you what these articles actually look like on an internet screen that I will share with you. So this is the article published by Pfizer on their data, and you can see the data was published on December 10th, 2020. Right, and the other one, it's a medical article published in the New England Journal of Medicine back in 2020 is this one, right? And these articles will tell you lots of technical details necessary for peer review, and you know, they have to make sure that everything was right and done carefully according to the scientific standards. So all the details are right here, and you can look at those things if you'd like. For my presentation, I will not be talking about all these technical details, but you can take a look at them if you'd like. All right, let me get back to those questions. So you will find that the essentially all the numbers you need to calculate the efficacy rate are right here, okay? This is the result of a very carefully conducted experiment by Pfizer. All right, so you can see that they had close to 40,000, actually a little more than 40,000 subjects in their sample, and they randomly divided them into the vaccinated group, which is the treatment group, and the placebo group, which is the control group. And for by the way, the placebo is a fake pill or fake treatment, which does not have any of the active ingredient of the vaccine. And so this is done in order to make sure that these people are not experiencing placebo effect. All right, so anyway, so this is these are the numbers, okay? And as I said, the numbers came from the Pfizer's press release as of December 10th, 2020. Okay, number one, what percent of those who received the placebo, basically those are the unvaccinated people, what percent of them were infected with COVID-19, all right? And so this, of course, is the probability that a regular person, a person without the vaccine, gets COVID-19, right? And so I hope you understand why this is true. In other words, if there is no vaccine available, this percentage of the general public would get infected. 162 out of 18,325. All you had to do was to calculate that. 162 divided by 18,325, and this turns out to be 0.00884 approximately. And so you can say 0.884% of the general public at the late part of 2020 were getting infected with COVID. Number two, what percent of those who received the vaccine in this trial were infected with COVID? And the answer, it's 8 out of 18,198. So we can do this division. You don't need any fancy calculators to be able to carry on these simple operations. Okay, so you get a number which is 0.044%. Okay, so these are the rates or the percentages of people who get COVID. The first one among the unvaccinated, and the second one among the vaccinated. Number 3, divide the answer to question 2 by the answer to question 1. So why are we doing this? Well, by dividing this number by this number, what we will be doing is to calculate what percentage of the people who get COVID without the vaccine would actually be getting COVID with the vaccine, all right? And so let me carry out this division first, 0.0440. This time I'm just using the percentage, okay? I guess I can just ignore that. Divided by 0.884, and this comes up to be about 0.0497, which is 4.97%. Okay, again, no advanced mathematics involved in any of these calculations. And what this says is 4.97% of those who would have gotten infected without the vaccine would still get infected with the vaccine, okay? It's important for you to understand and interpret these numbers correctly. All right, now finally, to get the efficacy rate, we subtract this from 100%, all right? So 100 minus 4.97% is going to give you 95.03%, okay? And so that is called the efficacy rate. Right? It's easy to calculate this. Now let's try to understand exactly what it means, okay? This number, as it says here, shows how many out of 100 people who would be prevented from the infection compared to a world in which vaccination is not available, all right? So if you take 100 people who otherwise would be infected with COVID without vaccination, would actually be 95 of those 100 people would be protected from being infected with COVID-19 if they are vaccinated, okay? So again, this percentage tells you what percent of the people who would get COVID-19 would be protected against that virus by getting the vaccination. All right, so I have several questions I want to ask you and think about in the second page. So let me go on to the second page of this. And by the way, you notice here, I rounded the numbers here and here. And so, you know, we have, of course, every time you round, there's a rounding error. If you didn't do all that, if you did all the calculations in one string of, you know, computations, then what you will get is this number here, 95.027, blah, blah, blah percentage. And so that's fairly close. The percentage error is minimal, right? So you can say that about 95.0% is the efficacy rate of this particular vaccine. All right, true or false? About 5% of all vaccinated people will get COVID-19. Okay, this is something I hear quite a bit, you know, like because the efficacy rate is 95%, does it mean that 5% of the vaccinated people still get COVID-19? And the answer is very false, okay? We know that already, that among the vaccinated, 8 out of 18,198 people, which turns out to be less than 0.05%. Okay, so it's a very small percentage of the vaccinated people who will actually get COVID-19. And if you look at the second statement, about 95% of people, the people who get vaccinated will not get COVID-19. You notice that it's the same thing. I mean, these are logically equivalent, so this is also false. All right, number 3. About 95% of all unvaccinated people will get COVID-19. Okay, this is also ridiculous, right? This is way too high, right? About 95% of the people who would get COVID-19 without the vaccine would be prevented from getting infected. This is exactly what that efficacy rate shows you, all right? So this is the correct and the true statement, okay? So if 100 people would have gotten COVID without the vaccine or before vaccination was available, then 95 of those people would not get the infected with COVID-19 if they are vaccinated. And that is what this number means. All right, so that's why they say the vaccine is 95% effective in preventing infection, because 95% of those who would have gotten COVID will not get it. if they're vaccinated. All right, so a better way to think about this maybe is this. If you split the population into the two groups, the vaccinated and the unvaccinated, okay? What this means is that for every 5 people, for every group of 5 people who are infected after vaccination, for every group of 5, there are 100 people here who are unvaccinated and get COVID. All right, so the ratio is of course 1 to 20, all right? And so that's exactly what that number is stating. So for every vaccinated person who get infected, there are 20 unvaccinated people who get infected. So people do worry, you know, what happens if I get vaccinated and if I still get COVID? Is that possible? Yes, it is possible. It's called a breakthrough case, which we will look at in a moment, okay? But remember, for one person who gets vaccinated and still gets infected, for one such person, there are 20 people who are unvaccinated and will come down with COVID. All right, another way of saying this is the unvaccinated are therefore 20 times as likely to get infected as the vaccinated. Now, let's talk about these breakthrough cases. Of course, these are the cases where a person still gets infected with COVID-19 after being fully vaccinated. Right? Data showed, remember, 0.0440% of the vaccinated people will have breakthrough cases. That's 8 out of the 18,190 in that particular trial done back in 2020. All right, so what does it mean? If half of the United States population, which is about 160 million, a little more than that, but you know, if the half of the population is vaccinated, how many such cases are expected? You multiply this by that rate, 0.0, actually, let's convert this to a decimal, 0.004, one more, 0.000440. If you multiply these two numbers, you get about 70,400. Is this a large number? Well, it certainly does look like a large number, right? 70,000 people. That's more than the crowd in the full Dodger Stadium. So is it true that many vaccinated people will still get infected? Unfortunately, yes. I mean, 70,000 out of half of the US population, you know, seem to be a large number, or is it? Okay, remember, it's less than 0.05% of those people who are vaccinated, right? So it is true, you could say that many vaccinated people can still get infected. And it's also true that many unvaccinated people will not get infected. Okay, these are both true statements, okay? But does it mean, do these statements mean that the vaccine is effective, is not effective because of these two statements? And the answer is no. You know, and they do not mean that the vaccine is ineffective, because as we saw, the percentage-wise, okay, and that's what you have to pay attention to. Percentage-wise, again, the unvaccinated are 20 times as likely to get infected. So if you are one of these people who are scared, well, you know, what happens if I get a vaccine and if I still get COVID? Okay, remember, your chances of getting COVID is 20 times as much if you are not vaccinated. So the vaccine reduces one's risk by 95%, and that is exactly what that efficacy rate means. All right. Now, I didn't mention this, but what about the side effects? Okay, if you look at those articles, and especially the second article in the New England Journal of Medicine, they will tell you that the serious adverse events did take place, right? In fact, 0.6% of the vaccinated people did suffer serious adverse events. That's terrible, isn't it? But wait, in the other group, remember the placebo group who did not get the vaccination, 0.5% of those also suffered serious adverse events. And these are, the difference between these is what we call a difference that is not statistically significant. Basically, they're about the same, which means that you don't really have to worry about the serious side effects. Do they happen? Yes, but very, very rarely. Okay, so these are the numbers that you need to consider when you start talking and thinking about vaccines and their effectiveness. So that is what the efficacy rate of a vaccine means. And remember, we didn't have to use any advanced mathematics or even calculus. All we needed was really division and subtraction. It's simple, but it's practical mathematics. In fact, I would go so far as to say it literally is a matter of life and death. So I hope you consider these numbers seriously as you make your own decision on vaccination. And remember, what you do will affect not only yourself, but your loved ones, family, friends, your community, the society, and ultimately the whole world. Thank you.